Yes, once again, I am Teacher Robinson Dongo, a mathematics teacher, St. Netarios Nursery and Primary School. Once again, I want to welcome you in this math lesson. Today, we are going to look at something very small and very brief, but it disturbs learners when we come to examination. This is one of the things that every year examination will not miss. It is the last topic of term 1 when you go to primary 4, primary 5, 6, and 7. It's the last topic of term 1. And this topic is called patterns and sequences. Some people used to talk about number patterns and sequences. Well, this is the same. So before we go furthermore onto this, I want us to discuss some of the keywords that we need to understand them very well before we go to the calculation part of it. The first thing here is what is called the patterns. When I talk about patterns, what does this one mean? The patterns is the order in which numbers are written. When I say patterns, I mean the rule or the order in which numbers are being written. For example, when I have this number here, number 20, number 40, number 60, number 80. When you look at these numbers, this number has been written, but they are following the order or the rules. For example, when you look at 20 and 40, there's something that has been done to 20 and to get 40. So that thing which we call, to know that thing, we need to carry out either subtraction or addition. Now when you look at 20 and 40, the difference between these is 20. Here also the difference between 40 and 60, the difference is also 20. The difference here also is 20. And when you try to see this very well, you will see that they were adding 20 to the next number or to the previous number in order to get the next number. So this rule of adding 20 is what we call patterns. Okay? So pattern is the order in which the numbers are written. So the numbers here are written by adding 20 to the previous number. For example, 20 plus 20, you are able to get 40. Here our previous number is 20. Now to go to the next number, we are going to add 20. Again here we have 20. To go to 60, we are able to add 20. So 20 plus 40, you are able to get 60. Again 20 plus 60, you are able to get 80. So for us to get the next number here, we are going to look at that one later. But now for us, we need to understand the meaning of the word patterns. Is the rule or the order in which numbers are written. Okay? So that is it. Then we come to this one. This one is done, we're going to this. It's called the sequences. When I talk about sequences, are a set of numbers written while following the rules. And that rule is what is called the patterns. We can write very many sets of numbers. Somebody can write 1, 2, 3, 4. Somebody can write like this. Somebody can count as 2, 3, 4, 3. When you say 2, 4, 6, 8. These are sets of numbers, and they are in series. So when you see this set of numbers, these are series of numbers. But they don't look, you cannot write any number here which is not following the order. So meaning a number in a series should follow the order. For example, 1, the relationship between 1 and 2 is by adding 1. So meaning here also we are going to add 1. Adding 1, adding 1. There is what is called the uniform relationships or the uniform patterns of numbers. So when it says sequences, it's just a series of numbers written following certain rule or order. Now, what about this is called the term? Any number or any number in the series is called a term. For example, the first number here is 20. So this one becomes the first term. This one becomes our second term. This one is our third term. Then this one is our fourth term. Now we are missing the fifth term and we are also missing the sixth term. And the missing terms are what we are supposed to get. Or normally, when they say find the next number in the sequence. And then we come to this. The word is arithmetic. Arithmetic sequence. What do we mean by arithmetic sequence? An arithmetic sequence is a series of numbers with uniform order or uniform patterns. When I say patterns, it's the order of which things are done. Like when we are adding 20, you keep on adding 20 throughout. When we are adding 1, you keep on adding 1. When you're subtracting 2, you keep on. That is what is called a uniform sequence. So an arithmetic sequence is a sequence which the patterns are uniform. That means they are constant. They have what is called constant patterns or constant relationship between them. Then there is what is called also non-arithmetic sequence. In non-arithmetic sequence, the patterns are not uniform. And in that case, it might also contain a combination of subtraction, addition, may also contain other operations, but they are no longer uniform. Others, you may be adding 1, you can find that sometimes you'll be adding 3, you can be subtracting. So these patterns are not uniform. The relationship between the numbers are not uniform. For example, when I have 2, then 4, then I have here 6, no, I have here, let me say 7, then I have here 8, let me say I have here 9. Then here also I have 12. You can see this. So when you look at the relationship here, 2 and 4, the relationship here is 2, because the difference between 2 and 4 is 2. What about here, the difference? 4 and 7, the difference is not 2, it is 3. Here the difference again is 2. Here the difference is 3. You can see this one here, the differences, the relationship in the numbers are not the same. So therefore we qualify such kind of sequences to be called non-arithmetic sequences. Then we come to this, these two are type of patterns, or the type of patterns. And the first one we call it increasing patterns, or increasing patterns. When we have a number, when you have a number or a series of numbers which are increasing, we call that one increasing patterns. But when we have the one which is, for example, when we have 2 going to 4, going to 7, going to 9, going to 12, the patterns here have been got just by adding. So this pattern, we call them increasing patterns because the relationship between them are just got by adding. And for you to get the next number, you just carry addition. But in other cases, we don't also use addition. Sometimes we can use multiplication. For example, when you have 2, you have 4, we have 6, we have 8. When you multiply 2 times 2, you'll be able to get 4. When you multiply 2 times 3, you'll be able to get the next 10. When you multiply 2 times 4, you'll be getting our next 10, which is 8. That means this one will be equal to multiply 2 times 5 will give you 10. So any sequence or series of number where the patterns are either got by multiplying or by addition, we call that one increasing patterns. Then we come to decreasing patterns. This one they hold about the rule, or the numbers are obtained in two ways. One, by subtraction. For example, let's look at these patterns. We have 20, we have 18, we have 16, and we have 14. Look at this. From 20 to 18, we are reducing. Now, do you reduce this? If you try by division, you will not do. But when you see subtraction, we say 20 minus 2, you'll be able to get 18. 18 minus 2, you'll be able to get 16. Then here, you'll be able to get 14. That means the next number in the sequence will also be subtracted 2. So this is what is called the reducing patterns, which are got by either subtraction or division. Let's try this. I have 27, and then we have 9, then we have clusters. For me to get this, divide this by 3. When you look at 27 divided by 3, you'll be able to get the next term, which is 9. When you look at 9 divided by 3, you'll get the next term, which is 3. Then this 3 here divided by 3, you get our missing, which is 3 divided by 3, 1. So this is an example of using patterns. So we have come to know all about keywords. The first one we say the keyword is called patterns, which refer to the rules or the order in which numbers are written. Then we have the sequences. These are the series of numbers written following a certain rules or order. Then the terms is any number which appears in the series of numbers. Then arithmetic sequences. These are sequences with uniform patterns. And the opposite is non-arithmetic sequences. These are sequences which the patterns or the order are not uniform throughout the numbers. And then we have increasing patterns, which we say that these are patterns where numbers in the series is increasing, or their patterns is increasing. And we say we do this by either addition or multiplication. Then we have decreasing patterns. We say these patterns, the numbers are obtained in two ways: one by subtraction, or by multiplications. So those are some of the keywords that we have. Before we learn about anything to do with finding the missing number in our sequence. Alright, so let's look at this example. These numbers, we are calling them the series. Here our first term is 20, The second term is 40, followed by 60, followed by 80, and we are told to find the missing terms. What do we do in this? To get the missing terms in any series, we need to first obtain the relationship between the numbers. So when you look at 20 and 40, we try to get the difference between the terms, where when we see 40 take away 20, the answer is 20, meaning it was 20 plus 20 that gave us the next term, which is 40. Let's look at 40 and 60. Yes, 60 take away 40, you still get 20. Meaning that it was 20 and you add to 40, that was how to get 60. And we also have the next term. When you look at 80 and 60, we have to have 20 and 60 to get 80. And then meaning that the two missing terms here, they will also follow the rules, and our rule is got by addition. So meaning here we shall also add 20. Here we shall also add 20. Now looking at this type of patterns, it is falling under increasing patterns, simply because the terms or the numbers are increasing. From down here, we are able to obtain our patterns, and you can see all the patterns are got by adding. So meaning this one falls under increasing patterns. And we look at the patterns or the numbers, the relationship between the numbers here are just uniform. Meaning this is what is called the arithmetic sequence. So when we try to add this 20 plus 80, 20, 80 plus 20, you will be able to get 100, meaning our next missing number after 80. When you add 20 to it, you get 100. Adding 20 to 8, 100, you get 120. So these are our two missing numbers in the sequence. Let's try this. We have 1, we have 4, then we have 2, then we have 8, then we have 16. After 16, we have 8 again. Then after 8, we have 32. Okay, let me say here is the missing number. Let's look at this series of numbers. We look at the first term to be 1. The second term is 4, followed by 2. Going to 8, we have 16. 8 again repeating itself. Then we have a dash. So the first thing to do is to obtain, to check whether all these numbers have the uniform patterns. So let us try to check from 1 and 4, what can we do to get 4? So we say we add 3, we're going to have 1 plus 3 will give us 4. When we go to this, we cannot add 4 to 2 to get 2. 4 to 2 is reducing, meaning we may subtract 2. When you take away 4 minus 2, you get 2. And when you come to this, you cannot add, when you add 3, of course it will not bring you 8. Here, when you try to subtract 2, it will not bring you 16. So what does this one mean? That means this way did not work. Let's try it the other way. But if we try by multiplication, here we multiply 1 by 4. 1 multiplied by 4, we get 4. And then from 4 to 2 is reducing. Instead of subtraction, why do we try by division? Divided by 2. 4 divided by 2, here we shall be getting 2. And then from 2 to 8 is again increasing. In increasing, we are multiplying here. Increasing the divided, meaning here we multiply also by 4. Now 4 times 2, you will be getting 8. And then from 8 to 16 is again increasing. Because here it should be, I should put 4 to make the work easy. So here is 4 times 2, you get 8. Now, meaning here we're going to divide. 8 divided by 2, you get 4. Then here, automatically, we go for multiplication, which is 4 times 4, you get 16. Then after multiplication, again go for division. Now 16 divided by 2 is again you get 8. So when you look at these patterns, the numbers here are multiplying, dividing, multiplying, dividing. So this one does not fall under arithmetic sequence, but they fall under non-arithmetic sequence. Meaning the patterns are mixed. We have first the multiplication, which we are multiplying is 10 by 4. Then here we have division, and here is multiplication. If we were having uniform rules or relationship between the patterns, we shall have what is called arithmetic sequences. So this is how sometimes we work. But you should also note that there are some patterns or numbers that fall under types of numbers. For example, if you look at this number here, let's look at number like 4, 6, 8, 9, 10. When you look at this type of numbers, you cannot say these are even numbers, but these are composite numbers, and they have more than 3 factors. But when you check the patterns between them, they are not uniform. You see, this one is got by adding 2, but here is again adding 1. There are only 2 numbers or patterns that they don't follow the rules. And we have those type of numbers. We have the prime numbers and the composite numbers. In this type of numbers, we don't obtain the patterns. What we only see is we study the numbers very well and we identify which number comes after the next number. And if you look at 11, I look at 10, the next composite number after 10 will be 12. And the next after 12 will be 14. So when you just identify them, you just write them there. Then to show to the examiners what you have done, you just open your bracket, then you state clearly the type of number. In this case, it is composite numbers. These are composite numbers. So when we are marking, we are looking at the number, and we shall also look at the reason why we put 12 and 14. If the reason is correct, from the reason here we are going to give you bonus 1. Then from the missing value that you got, we shall also award you some marks. It will also apply in numbers like prime numbers. In primary 4 and primary 5, we say that prime numbers, these are numbers that have only 2 factors, and that is factor 1, the number itself. The first prime number is 2, go to 3, go to 5, go to 7, go to 11, go to 13, go to 17, go to 19. Then when somebody says find the next number in the sequence, then you see this series. There is no need for you to obtain the patterns. The work here is just to be able to say what type of numbers are these. And obviously you will know that these are prime numbers. So what prime numbers come after 19? Automatically, after 19 is 23. Then after 23, we go up to 29. So after writing just 75, then you open the bracket and just state the type of number. These are prime numbers. So it means that certain sequences that we don't need to obtain the patterns, but we just start them. And this, we have the composite numbers and the prime numbers. But other type of numbers, they have their uniform patterns. Like prime numbers, no, like even numbers, you get them by adding 2, 2, 2. Odd numbers, you get them by adding 1, 1, 1. Whole numbers, the same. Counting numbers, the same. So that is all I have for you now. I wish you the best as you prepare for your examination. This is 2026. I expect really to be very simple, because from the policy we understand a year that divides with 2 and need no remainder, always the exam they say is very simple. So this year our exam will be very simple. So I wish you the best and God bless you.